Hi, my name is Andrew McLaren, and I want to help you with acid-base questions. This is the very foundation of doing these problems, is knowing how to convert between pH and concentration H, as well as pOH. And a lot of students will understand the relationship, but when they do the stuff on their calculator, they kind of get it backwards or messed up. So my tip here is to basically just make a table and convert between these two things in that table. That will tell you what you need to do math-wise for your particular number in a question. So you should have this on a test just made so that you can refer to it. So if I had a pH of 10, then that's going to be 10 up to the negative 10 for its concentration of H. If I had a pH of 7, then that's going to be 10 up to the negative 7 for the concentration of H. And you can do this for as many values as you need. I'm going to do two more values. So if we've got pH of 2, and you've got 10 up to the negative 2. And then when people kind of struggle on this is more of like when we've got values that are like not whole numbers. So if I had something like, I'm just going to do 3 and 10 up to the negative 3, then we can try and think about, well, what if I had something that was kind of between those two values, and what is that going to be in terms of like the pH or the pOH? So if you can think about this in pH and concentration of H, I'm going to extend this table and highlight these situations also with the concentration of OH minus. And yes, I know I'm using improper terms, but this is how most students refer to these things. So I'm just going to work with that. So if you've got a pH of 14, you do know that pH plus pOH adds up to 14, which is kind of like how the concentration of H plus and OH minus is equal to the KW, which is going to be 10 up to the negative 14. And you can kind of plug in some of these numbers. So if I had a pOH of 10, or sorry, a pH of 10, then the pOH would be 4, which is, in other words, saying if this is 10 up to the negative 10, then this would be 10 up to the negative 4. So if you can see that this would be like the pOH of 4, then this is 10 up to the negative 4 for the concentration of OH. Same sort of deal here. If this is 7, then the pOH has to be 7, and you're going to have 10 up to the negative 7. And if you think about this in a broad sense, this is just your exponent rule, where you've got these two numbers being added up when you multiply two bases and you're thinking about the exponents. Because you can see that we've got 10 up to negative 10, 10 up to negative 4. When those multiply together, you get 10 to the negative 14. We can then also think about 3. That should be with like 11. And this would be 10 up to the negative 11. And if you have 2, then this is 12. And this is 10 up to the negative 12 power. And a lot of people then are able to relate those whole numbers. But let's say that you had something where it was like a pH of like 2.5. You could think about this as 10 up to that negative 2.5, but that's not really normally how this is written. We usually have it in scientific notation, which looks a little bit different than what I just wrote out there. But you can use your calculator to actually do this calculation for you. So you can take 10 and you can put it up to that 2.5 power, or the negative of that 2.5, and see what it comes out as. I'm getting 3.16 times 10 up to the negative third power, which should seem reasonable because it's somewhere between the negative 3 and the negative 2 for those exponents. It's a little bit bigger than one and a little bit smaller than the other. Because it's a negative exponent, sometimes I get a little bit thrown off by this. But remember that this is smaller, and this is bigger. So you're going to have that smaller place value, and it's not exactly 1, but like 3 is somewhere between 1 and 10 is how you want to think about this. So you can then also work with the pH and pOH, and I prefer to do those because it's just cleaner. So oftentimes if I'm given concentration of H, I will take that value and be like, well, what's the log of that? And then change the sign on it. And that'll help me kind of go from that concentration H to the pOH. Then I'll subtract that from 14. So we got that 14 minus the 2.5. So this is 11.5. And you can kind of see in the context of this table, it's not too bad to think about these numbers. And then the concentration of OH should be 10 up to that 11.5 power, or the negative 11.5 power. And I'm getting 3.16 times 10 to the negative, what is that, 12th power? And that works out nicely. And if you were to take like 3.16 times 3.16, well, that gives you about 10 when you multiply those two numbers together. So the negative 3 and the negative 12, yeah, that when you multiply those, you get 10 to the negative 15, but it's 10 times 10 to the negative 15, which is 1 times 10 to the negative 14. So you can kind of see that relationship there. I am going to highlight a different example where it's not 0.5, so you can just kind of see how this works. If I had, like, let's go with 5 times 10 to the negative 10 power there. Let's see what that is as a pH value. Now, because this isn't a linear relationship, 5 for this is not exactly halfway between the two in terms of the exponents that you'd be looking at. So if we have 5 times 10 up to that negative 10th power, then you can kind of see in the calculator that's what we've got. And you can take that and you can say, well, what's the log of that? And I'm getting a 9.3 for the pH for that. You can then go ahead and see what that pOH would be. So if you've got 14 minus 9.3, I'm getting 4.7. And if we do 4.7, so we take 10 up to that 4.7, a negative power on that, then we can see that we're getting about, it's about 2 times 10 up to that, what was it, negative 5th power. And you can see that you've got like 2 times 5, which is going to give you 10, and then the 10 up to the negative 10 times 10 up to the negative 5, that's 10 to the negative 15. So 10 times 10 to the negative 15 is the same as 1 times 10 to the negative 14. In other words, if you are moving the place value over here, making this 10 times smaller, then you need to make this 10 times bigger to get that 1 times 10 to the negative 14. So if you get that overall relationship, then you should be able to solve for any pH and pOH. And just as a bonus, this is a bit of an extension, but if you wanted to think about Ka and Kb, this is the same sort of trick that you can use when you're solving for Ka and Kb. You can also work with pKa and pKb, adding up to that that 14 as well. So if I had an acid that had a Ka of 1 times 10 to the negative 3, then the Kb value that goes with that, the strength of the conjugate base, would be 1 times 10 to the negative 11. So the acid is a bit stronger than the base, in other words. You can look at the pKa and the pKb is adding up to 14 in the same sort of sense as what we were talking about earlier. These are different concepts, Ka, Kb, and pH and POH, but they have the same sort of math tricks right behind them, so you can use them to relate between those two. So if they've given you the strength of a weak acid, you can figure out the strength of the conjugate weak base. So yeah, that's my biggest tip, is being able to work with this table, using some math tricks to help you navigate through these. A lot of people have a hard time with like the 0.5 not just coming out as halfway between the two numbers, but you can see in the numbers that we've done here the actual relationship and how that works.